Hello students, welcome back. This is SHIVALEELA from Upper Public School. In the last clipping, we have solved exercises, right? So in the last clipping, we have solved 7.5. In that exercise, we learn to add like fractions. Now, in this exercise, we are going to add and subtract unlike fractions. See, while adding or subtracting unlike fractions, there are the methods. So the most familiar method is Lcm method. That is the most known method we can see. Okay. Another one, I used to say to my students, if you are finding difficulty there, you can use these methods. That is, one is converting unlike as like fractions and then adding. Another one is cross multiplication. But we have to use all these three. When and all, I'll say them. Okay. First one itself, it is 2 by 3 and 1 by 7. See, if denominators are co-prime, okay, if the denominators are co-prime, use cross multiplication method. Okay, if the denominators are not co-prime, use Lcm method. See, both are one and the same. If denominators are co-prime, their LCM will be the product of these two only. See, let us check it. LCM of 3 and 7. 3 and 7. 3 ones are 3, 7 will be as it is, 7 ones are 7. So LCM will be 21. Right? So when these denominators are co-prime, then use cross multiplication method. How? Come on, I'll see. 2 sevens are 14 plus 3 ones are 3 divided by 3 sevens are 21. Okay, next. 14 plus 3, 17 by 21. The same problem I'll explain using the LCM method also. See, LCM just now we got see, LCM. So 3 and 7, 3 ones are 3, 7 ones are 7. I mean ones are 7. So LCM is 3 into 7, that is 21. So in this case, 21 will be in the LCM denominator. And in 3 table, when will you get 21? 3 sevens are. In 7 table, 3s are. These you have to multiply. 2 sevens are 14 plus 3 ones are 3. It is nothing but 17 by 21. Both are saying no. Isn't it? One more method, that is making denominator same. The same number I'll take. No. For the next problem. Okay. So the second one. B1. So B1, 3 by 10 plus 7 by 1. In this case, see, it will be very useful if we make denominators same. Now denominators are not co-prime. Then what if we use cross multiplication method? You won't get wrong answer, you will get correct answer only, but in equivalent form you will get. Okay, see, for example, if we multiply, cross multiply, 3 5s are 15 plus 7 10s are 70 divided by 10 5s are 50. If we do that, we will get 70 plus 85 divided by 50. Both are divisible by 5. So if we divide it by 5, we will get 5 ones are 5, 5 sevens are, 5 tens are. So 17 by 10 we will get, right? So if we use LCM method, see, if we use LCM method, LCM of 10 and 5 is 10 only. 10 and 5, LCM is 10 only because it is common multiple. What is meant by LCM? Least common multiple. See, 10 is the common multiple of 10 and 5 both. And this is only the smallest one. So therefore, 10 is the LCM. Okay, or else you can find it like this also. 10, 5. 5 2s are 5 ones are, 2 ones are. So LCM equals to 5 into 2, that is 10. Okay, then 10 is the LCM. In 10 table, 1s are. In 5 table, 2s are. So 3 ones are 3 plus 7 twos are 14. So 17 by 10 you will get. Same answer. If we make denominator same, see, 10 is there. See, this is 10, this is 5. In 5 table, we'll get 10 directly when 5 twos are, right? So 3 by 10 plus 7 twos are 14 by 10. Denominator is same, add up the numerator. 3 plus 14, that is 17 by 10. See, there are plenty of methods. Which is easy for you, you can. Okay. For what I'll do now is for few problems, I'll use cross multiplication. For few problems, LCM method. Okay. But for which, if the denominator is same, I mean not co-prime, then I'll say I use cross multiplication method. If denominators are not co-prime, then I use LCM method. Is it okay? And one more thing, I'm not going to solve all problems for you. See, few problems are similar. Now for A and B, I have solved. Remaining C, D, and E and F. These 4 problems are similar. Denominators are co-prime. Okay, use either cross multiplication method or LCM method to solve. It is your work. You know, no. Every time I'll give one of the other problem for you, isn't it? Now, in this bit, I'll give few problems. Now, these 4 problems. Later, I'll give last M and N problem for you only to solve. Okay. Now, come on. Subtraction I'll do. G1. Directly I'll go to G1. A and B over. Remaining C, D, E, and F is your work. Okay. Now, G1. 3 by 4 minus 1 by 3. Okay. See, same. Just instead of plus, it is minus. That's it. See, denominators are co-prime. So what I'll do? Cross multiplication. 3 3s are 9 minus 4 1s are 4. Denominator 4 3s are 12. Okay. Now 9 minus 4 5 by 12. That is the answer. Over. Very easy. Within a fraction of seconds you can, if you understand the concept. Got it? Yes. Next one, H1. H1. 5 by 6 minus 1 by 3. In this case, LCM method. See, no need to go through this method only to find LCM. If the numbers are smaller, bigger number, prime factorization method is very easy. If the numbers are smaller, then what is the other way? The trick to find LCM. See, how many numbers are there? 2 numbers are there. Among these 2, choose bigger one. Okay. Now even here also, among these 2, choose bigger one to find LCM. Okay, I'll take this example like this. 4 is a bigger number among these. Now go on saying 4th table. Which number will be common for both? That is only the least common multiple. 4 1s are 4. That is not in the 3 table. Leave it. 4 2s are 8. That is also not there in 3 table. Leave it. 4 3s are 12. That is there in 3 table also, isn't it? That's why 12 is the LCM. Did you get it? Okay. Yes. Now here 6. 6 1s are 6. That is there in both the table. So therefore LCM is 6. 6 1s are 6. 3 2s are 6. So 5 1s are 5 minus 1 2s are 2. So 5 minus 2 is 3 by 6. Now both are divisible by 3. Equivalent fraction. So 3 3. 3 1s are 3. 3 2s are 6. Over. Got it? Yes. Now I1. Two by 3 plus 3 by 4 plus 1 by 2. Same. Denominators are different. Here you can say, ma'am, can we do cross multiplication? You can, but cross multiplication is only for 2 numbers, 2 fractions. So first, do for these 2 fractions, you will get 1 fraction as answer. Then that one and this one. Again you will get 2. Again cross. It will be lengthy method. In this case, use LCM method. See, directly you can find LCM like this. Okay, 3, 4, 2. 2, 1, 3 will be as it is. 2 2s are 2 1s are. Again, 3 will be as it is. 1s are 3 1s are. Okay. So LCM will be 2 into 2 into 3. That is 12. I'm writing too small. Why? Because I'm using another trick, not a method. It is just a trick. Because this one here, we are not providing marks for this. Isn't it? You should know this. It is already you have learned in 3rd chapter. Isn't it? So here, for small numbers, simply why you are wasting time? Use some trick. What is that? Choose the bigger one. 4. Go on saying this table. 4 ones are 4. It is there in 2 table but not in 3 table. 4 twos are 8. It is there in these 2 table but not in 3. 4 threes are 12. 12 is in 2 table. 12 is in 4 table. 12 is in 3 table. So therefore, 12 will be the LCM. See, here also we got LCM 12 only. Isn't it? Same. See, anyhow, like this you can or else like this. No problem at all. Okay. Now, 3 4s are 12, 4 3s are 12, 2 1s are 12. Now, 2 4s are 8, 3 3s are 9, 1 1s are 1. Sorry, 2 6s are 12. What is this here? 2 6s are 12, not 1s are. So, 6, right? So, add up. 8 plus 9, 17. 17 plus 6 is 23, right? Then divide by 12. This is improper fraction, isn't it? So we can convert it into a mixed fraction. So 12 ones are 12. See, 12 twos are 24. But it is 23. That means 12 ones are 12. Still 11 will be remaining. Got it? Yes. Next one then. I, J. 1 by 2 plus 1 by 3 plus 1 by 6. Add. You see here. Again, just like this only. I'll choose this bigger one. 6 is in 3 table and 2 table also. So LCM is 6. 2 3s are 6. 3 2s are 6. 6 1s are 6. So 1 3s are 3 plus 1 2s are 2 plus 1 1s are 1. 3 plus 2 5. 5 plus 1 is 6. I'll write here 6 by 6. It is nothing but 1. Got it? Very easy, isn't it? Yes. Now, let us go to next one. Okay. Here, in next problem, you have mixed fractions. See, 2 fractions over with the different denominators. And that too, when all the denominators are co-prime each other and when they are not co-prime. Okay, in all the cases over now. 2 fractions and 3 fractions over. Now, mixed fraction. Okay. K1. 1 integer 1 by 3 plus 2 integer 2 by 3. I mean, 2 integer 2 by 3. See, yeah, again here also, we have 2 methods. One, first add whole parts and then add remaining parts. Like 1 plus 2 plus 1 by 3 plus 2 by 3. What we did here, we added. Okay, is this, okay, it is 3 integer, okay, not 2 integer, 3 integer, 2 by 3. 3 integer, 2 by 3. Okay, 1 plus 3. So, we are adding whole part ones and fractional part. That is 4 plus 1 plus 2 divided by 3. Because denominator is same. So, 4 plus 3 by 3. This is nothing but 4 plus 1 is 5. Okay. For the same thing, I'll explain another method. 1 integer 1 by 3 plus 3 integer 2 by 3. Which method? Convert them into improper fractions. See, 1 3s are 3 plus 1. 4 divided by 3 plus 3 3s are 9 plus 2. 11 by 3. Add up. Denominator is same. 4 plus 11, that is 15 by 3. This is nothing but 5. See, any difference in the answer? Got it? There is no difference at all. And in case of minus, if it is minus, here we have to subtract. In case of plus, plus. In case of minus, minus. This one we should know. Okay? Either we can do like this or we can do like this. As your wish. Okay, you can, no problem at all. But don't get confused here in the subtraction. If it is subtraction, this also will be subtraction only. So this may confuse you. For this was the very easy numbers, I mean fractions we could get the answer. But this is comfortable for you. Very easy also. That's why. Okay, we'll follow this method. Okay. Now, L. Okay. 4 integer 2 by 3. 4 integer 2 by 3 plus 3 integer 1 by 4. Come on. First, convert them into improper fraction. How? Multiply these two and add this one. 4 3s are 12. 12 plus 2, 14 by 3 plus 3 4s are 12 plus 1 is 13 by 4. Okay. Now, denominators are different and that too co-prime. Cross multiplication or LCM. Both are one and the same. Okay. So, 14 4s are 56 plus 13 3s are 39 divided by 12. 3 4s are 12. LCM method. See, 3 and 4 both are co-prime. Their LCM will be the product of those two numbers only. So 3 4s are 12 is the LCM, and 3 4s are 13. I mean 4 3s are. These two numbers you have to write. You will multiply. You will get this one. 56 plus 39. See, okay, there is no difference. This is actually why I am saying. See, this is very easy for few students to catch. This is the formal method. It has to be followed in mathematics. This is mathematical only. There is no trick, nothing. The same thing using trick, what we say. Smart work, we'll say no. That one is this. Okay? Don't get confused what is the difference in these two. For you, if it is comfortable, LCM method, you can, no problem. For you, if it is confusing, you can go through this method, no problem at all. Okay? Yes. Add up. 6 plus 9, 5, 15. So, 5 plus 1, 6. 6 plus 3, 9. 95 by 16. 12. 12 8s are 96, but it is 95. Improper fraction. Convert. So, 12 7s are 84. Still 11 will be remaining by 12. Okay? And M and N, both are your homework. You have to do it by yourself. Now, let me go to the next problem. See, whatever I'm saying you to do yourself, try it. Okay? Don't think anyhow Miss will give the answer in the next clipping. For these, I'm not going to give answers in the next clippings. Okay? Try it. Try to solve yourself. If you doesn't get, watch this video once again. Pause, go back. You will get to know. Okay? Because same method is followed. There is no difference at all. Okay. Next one, we'll go to this next problem. That is, Sarita bought 2 by 5 meters of ribbon, and Lalita bought 3 by 4 meters of ribbon. What is the total length of the ribbon? Don't get confused. Very easy. See, instead of fraction, if it is given, Sarita bought 5 meters of ribbon and Lalita bought 4 meters of ribbon. What is the total length of ribbon bought by both of them? See, very easily, you will get the answer. Fraction of second answer you will get. Very easy. 5 meter from Sarita, 4 meter from Lalita, total 5 plus 4, 9. Easily, right? Same thing you have to do here also. Okay, no changes at all. Same thing. But instead of whole number, we are having a part of whole. That is nothing but fraction, right? Yes. See here. Length of ribbon. Length of ribbon bought by Sarita. It is 2 by 5 meter. Is it visible? Yes. Next. Length of ribbon bought by Lalita. That is 3 by 4 meter. Okay. Now, add up. Total length 2 by 5 plus 3 by 4. Denominators are coprime. LCM of two coprime numbers are always the product of given numbers only. So LCM will be 20 because 5 fours are 20. Then in 5 table, 4s are. In 4 table, 5s are. So 2 4s are 8 plus 3 5s are 15. That is nothing but 23 by 20. Improper fraction. 20 ones are 20. 3 will be remaining. Okay, therefore total one integer, not a 2. Okay, one integer 3 by 20 meter of ribbon bought or purchased, bought by both of them. You can change this sentence. Okay, no need to copy from the board as it is. You can change it as your wish. Next, third one. Naina was given. See, I did not even rub it. Naina was given 1.5. That means one integer, 1 by 2 cake. Piece of cake. And Najma was given one integer, 1 by 3. Okay, piece of cake. Third one. Naina bought one integer, 1 by 2 piece of cake. Okay, piece of cake. And Najma was given one integer, 1 by 3 piece of cake. Then find the total amount of cake. Find the total amount of cake given to both of them. Okay, cake given to both of them. Come on, same thing. See, if instead of fraction, mixed fraction and all, if whole number is given, Naina bought not bought here, it is given. Okay, Naina was given. If Naina was given 3 pieces of cake and Najma was given 4 pieces of cake, total 3 plus 4, 7 pieces. Same way, here fraction. That's it. Okay, come on. Cake given to Naina. Piece of cake also you can write. Okay, piece of cake or amount of cake, part of cake, you can, no problem. Okay, is one integer, 1 by 2. Convert it, or else while adding only you can convert, no problem. Anyhow, as your wish. Okay, anyhow you have to add, right? Given to Najma. which is 1 integer 1 by 3. Convert. 2 ones are 2 plus 1, 3 by 2. 3 ones are 3 plus 1, 4 by 3. Then total 3 by 2 plus 3 by 2 plus 4 by 3. Now 2 and 3 denominators are co-prime, isn't it? See, it is confusing, not one right. 2 and 3 are co-prime. Then LCM product of these two. 2 3s are 6. 2 3s are 6. 3 2s are 6. 3 3s are 9 plus 4 2s are 8. That is nothing but 17 by 6. Isn't it? 6 2s are 12. If you doesn't know that directly, you can do like this also. 6 2s are 12. 5 is remaining. So 5 integer by 6. I mean 2 integer by 6. And therefore sentence, you can write by yourself. Okay, or else I'll write here. Therefore, 2 integer 5 by 6, piece of cake or pieces of cake. Okay, or piece of cake. Pieces of cake is given to both of them, Naina and Najma. Okay? Yes. Now, next bit is fill up. Okay? Next bit is fill up. Already we have solved this type of problem, right? In the last exercise, in 7.5, we have filled the blank. Same way here, but there denominator was same. So addition and subtraction was very easy there. But here denominator is different. But now that is also easy for us because just now we learned it, isn't it? So come on, let us do that now. Okay. So I introduced one more concept last time, that is a transposing the fraction from one side to another side. Okay, transposing the fraction from left hand side of the equal sign to right hand side of the equal sign. Right. Fourth one, fill in the boxes. Fill in the boxes. Okay, A1 dash, I mean box, minus 5 by 8 equals to 1 by 4. Come on, very easy. See, we want box value. Keep it here only. On the RHS, we have 1 by 4 as it is. We are transposing this one to this side. So minus will become plus 5 by 8. Now denominators are not co-prime. Denominators are not co-prime. So LCM 4 and 8. See, 8 is in both the tables. 8 ones are 8 and 4 twos are 8. So therefore the common multiple is also 8 only. LCM is 8 only, or else you can go through this. Okay? 4, 8. 2 twos are 2 fours are. 2 ones are 2 twos are. 2 ones are 2 ones are. So LCM 2 into 2 into 2. 2 twos are 4, 4 twos are 8. Right? Yes. 4 twos are 8, 8 ones are 8. So this is the 2 plus this is 5. That is nothing but 7 by 8. So therefore, box value is 7 by 8. Therefore, 7 by 8 minus 5 by 8 equals to 1 by 4. You may get confused. How is it possible? See here, denominator is same, 8. Numerator, 7 minus 5. 7 minus 5 is nothing but 2 by 8. We got 2 by 8, but they gave answer 1 by 4. Is there any relation? Yes, they both are equal, equivalent fraction. Both are divisible by 2, no. So 2 ones are 2 fours. Correct? Yes. Very easy, isn't it? Yes. Now, B1. B1 dash means box minus 1 by 5 equals to 1 by 3. Same way. See, we want box value. Keep it here only. And The half means 1 by 2 is on the RHS. We are not going to do anything for that. We are keeping it as it is. We are just transposing this one to this side. Okay, so minus 1 by 5 will be plus 1 by 5. Now, both are co-prime. So LCM is the product of both the numbers. 5 2s are 10. So 2 5s are 5 2s are. So 5 plus 2, that is 7 by 10. So the box value is 7 by 10. So therefore, 7 by 10 minus 1 by 5 equals to 1 by 2. How is it? Solve. See, we'll get to know. 10 is the LCM. 10 ones are 5 2s are 7 minus 2. This is nothing but 5 by 10. 5 ones are 5 2s are. So 1 by 2. Got it? Yes. Very easy. Isn't it? Next, third one. C1. That is 1 by 2 minus dash equals to 1 by 6. Right? Now, see, box value is negative. See, till now we did positive, no? Let us do it positive. See, this is negative. As I said, when we transpose the number from one side to another, it will change its sign, no? So now let us transpose this box only. So we'll get half equals to 1 by 6 was there only. We are not going to change it. This will be rigorous. Okay? Now, I want only this one, not a plus this. So now, transpose it. Okay, that I'll use another ink. Transpose this. Half is plus only. We are not going to change it. This plus 1 by 6 will be minus 1 by 6 equals to box value. If you get confused here, you just rewrite it. This one, see on this RHS, you just bring it to LHS, that is plus 1 by 6 equals to LHS, you just take it to RHS. Now you may find it out very easily. So half, this is transposing minus 1 by 6, not co-prime. Then bigger one, 6. 6 is in 2 table also. So therefore LCM is 6. 2 3s are 6, 6 1s are 6. So you will get 3 minus 1. That is 2 by 6. Both are divisible by 2. Right? So 2 1s are 2, 3s are. Right? So therefore box value is 1 by 3. Therefore 1 by 2 minus 1 by 3 equals to 1 by 6 is the solution. Oh, it's almost around 32 minutes. Little bit. So today's homework. First bit, C, D, E, F, and last M and N. Okay, solve those problems, and we'll meet in the next clipping with a few more problems remaining in this chapter. Okay, in this chapter, next problem itself, I have a box. First box is your homework. Next one, I'll do. Try it. If it doesn't get, no problem. In the next clipping, I will solve the next bit. That is B1. Use the same concept and apply it for A1 also and do it by yourself. Okay? So we'll meet in the next clipping. Until then, keep solving these problems. Okay? Bye-bye.